we are starting tests of significance, which, if you excuse the pun, is a very significant section of statistics. The beginning of tests of significance is talking about sampling distributions. And so this whole video is really about what is a sampling distribution. We'll start with a question. How many chunks of cookie dough are there in a pint of Ben & Jerry's cookie dough ice cream? Well, if we wanted to know that, I suppose we could grab a simple random sample of maybe 35 pints and count the number of chunks. And so here's our sample. All right, we have 35. I haven't listed all of them. It'd be an awful lot. All right, so pint number 1 has 38 chunks. Pint number 2 has 42 chunks, and 28, and all the way down, pint 35 has 35 chunks. And so you can see, as a manufacturing process, there's natural variation that we would expect. We could average all of these, and we could get a sample mean, which in this case is 36.2. So the question, or I guess the question is about the answer, is this the answer to this question? How many chunks of cookie dough? Is there 36.2 chunks? Well, maybe. If we took a different sample, would we necessarily get 36.2 again? Well, we take another sample, we get this, and of course no, because there's variation. The sample is going to be different than that sample, so the means are going to be different. So now, of course, this throws us into a bit of a quandary. We're still trying to answer this question. How many chunks of cookie dough? Is it either of these? Well, what happens if we take a third sample? Well, of course, we would get different results, slightly different mean. We're generating all of these means. Let's graph them. When we start getting confused, we're not quite sure where this data is heading, let's try and draw a picture. So I'm going to draw a dot plot. Here is my axis. Right now, these are continuous now because it's an average, 36.2. Right? Notice that these are, not decimal numbers, because you have 38 chunks or 39 chunks, but as an average, we have, decimal numbers. So I'm going to do this as, intervals. So really, 36.2 is going to be between 36 and 37. And so these three means will come up on my dot plot as this. Well, that's not much of a picture, really. Don't get a good understanding. So looks like we need to have more than 3 samples. All right, this is now 7 samples. Enough samples to get a good picture? Nah, doesn't look like a very good picture yet. Let's take 14 samples. Well, we're starting to see maybe a symmetry, a mound shape developing here. 14 doesn't seem to be many, though. All right, so this is 25 samples. We're definitely starting to see a number of nice symmetries and shapes emerging. Let's actually bump it up a little bit more. This is 44 samples. You can see it goes all the way up to 44. And we have a really nice regular shape, mound shape symmetric. And so I think maybe we can stop at 44. We don't have to take any more samples to get an idea of this sampling distribution. So to answer the original question, what is a sampling distribution? We have it right in front of us. Right? This is distribution of sample means. We're not always going to be talking about means just to kind of seed an idea for the future. Sometimes we're going to talk about proportions, distribution of sample proportions, but that's going to be a little while from now. It's a little bit easier to talk about means, I think, because we would expect distribution of means. Not every pint's going to be the same, so not all the samples will be the same. At this point, I'd like to actually talk about an important distinction. And that is, a population distribution versus a sampling distribution. Now, what we have here are, of course, sample means. These measurements inside the samples are really population measurements. Right? Now, we don't have all of them. And in particular, let's look at this one pint. Right? Pint number 2 of sample 44 had 45 chunks of cookie dough. Now, if we look at our number line down here, 45 doesn't appear anywhere in this graph. Well, 45 is an awful big number. But notice that there are 35 numbers that all get averaged in, 34 other numbers with this 45. And so there's sort of an internal balancing that ends up happening here. This is an unusual value, but it kind of gets washed out a little bit by averaging it with 34 other numbers. And so this 38.5 is, one of these values, and doesn't seem to be overly unusual. So that's actually one of the benefits of doing the sampling routine, is it kind of pulls in the variation. 45 just doesn't even appear in this distribution because it's inside one of these dots. And it's been balanced with a bunch of other values. So you don't get quite the swings that you would if you actually did a population distribution. If we graphed the population, there would be the value of 45 in that graph. But in the sampling distribution, it's been kind of included in the average of one of these sample means. Now that you basically know what a sampling distribution is, it doesn't actually come in the form of dot plots usually. So let's look at this dot plot. And what we could do, a more typical form, let's look at it as a histogram. So there are 11 dots here, 7 dots, 3 dots, 1 dot, and you can see that has this, again, this nice mound-shaped symmetric distribution. Now, if we look at this as a frequency table, it would look something like this. What we want, the direction that this goes in, is a probability. Right? So we want to be able to ask the question, what's the probability of a certain sample mean happening? So if we want probability, in this particular case, we would take the frequencies, like 7, and we divide it by the total number of samples, which is 44, and we'd get the probabilities, which would be something like this. And we could graph them, and of course the shape of the graph would be identical. Really just the numbers are changing because every number is divided by 44, a constant, so the shape doesn't really change. And here we have this nice probability distribution. Well, now that we have a probability distribution, we can look at it and start asking all those wonderful probability questions that we know and love, such as, what is the probability that a randomly selected sample will have a mean equal to 34 chunks of cookie dough? Well, 34 is this interval right here, so you can already see the answer is going to be 7, the way you'd write this out. Probability of the sample mean, x bar, equaling 34, 7%, and we have our answer of 7%. We can, of course, ask, what's the probability of a randomly selected sample that will have a mean that is at least 38 chunks of cookie dough, right? The whole at least thing. Well, we've done that before. It's going to be 38, 39, and 40. There is nothing past 40. So you add them together, and probability is 25%. That's really, the basics of sampling distributions. Now, what's going to be important is, where is all this heading? Because, it's going to get a little bit more complicated. And in what ways? Well, let's think about this question. Ben & Jerry's just got a new cookie dough machine that is set to drop 37 chunks, just like the center of our distribution that we made. That seems to be the goal. All right, so 37 chunks of cookie dough into each pint of ice cream. All right, this is a new machine, so a simple random sample of 35 is taken to make sure that it's working properly, and the sample mean of this simple random sample turns out to be 32.2. Right? So the question is the machine functioning properly? If not, what kind of adjustment would it need? Now, what I'm going to ask you to do is write the answer down on a piece of paper and please hand it in to me. This is a homework question. What you are going to want to do is look back at this sampling distribution, and that's going to tell you, where is the 32.2 in the sampling distribution? Once you've located it on the sampling distribution, and of course 32.2 is over here, what is that telling you about how the machine is functioning? So, where is this all heading once you've actually thought about that question a little bit? Now, the question above can really only be answered because we have already produced a sampling distribution. Notice that I showed you, you have to take this 32.2 and locate it on the sampling distribution, which means we have to have the sampling distribution to answer this question. Well, each sample had 35 pints of ice cream, and it took 44 samples. That is 1,540 pints of ice cream. That's a lot of ice cream. If we weren't talking about ice cream and we're talking about like gold or diamonds, that could be prohibitively expensive, and we simply couldn't produce the probability distribution or the sampling distribution. Now, very important, under certain conditions, that's an important statement, sampling distributions have been shown to be quite close to standard known probability distributions. This is crucial. Right? What it means is that we won't have to draw a large number of samples. In fact, we won't have to draw any samples to identify the sampling distribution. What we have to do is know about these certain conditions. If these conditions are met, then we already know, we can identify the sampling distribution. So the rest of this time is really going to be talking a lot about, well, what are these conditions? And there's going to be a bunch of them. And a lot of students, find that part kind of hard. You have to kind of keep track of all the different conditions and their different calculations depending on the different conditions. But we'll go through them kind of slowly and, in an organized way, and hopefully that will help. Now, the first two standard probability distributions that we'll talk about are the normal distributions. We've talked about normal distributions before, and the t-distributions. Or distribution. Now, when we are talking about these distributions and the conditions, what we're going to have to know or calculate, and this is straight from the beginning of the school year, shape, center, and spread. All right, so there's going to be, spread is standard deviation. There's going to be a number of different ways of calculating it depending on what conditions are present. And so we're going to be spending a lot of time talking about how to calculate center, shape, and spread for the different conditions. And that's going to be the next video.